Welcome to the deep dive. Today we are going to break down the science behind non-oral auditory perception.
Right.
We're talking about the tech often called voice-to-skull, or V2K, and these silent sound systems.
And we're going to get into the weeds here, pulling from, engineering, physics, and even a bit of neurobiophysics.
So where do we start?
We have to start with the core mechanism. It's called the Frey effect.
The Frey effect.
And this is in theory. This was an actual byproduct discovered during early radar testing. It's the perception of sound from pulsed electromagnetic energy.
Okay, so let's get this straight. The key detail is how you're hearing this. It's not coming through your eardrum.
Not at all. The EM pulse is absorbed, and it creates this incredibly small, rapid temperature change.
How small are we talking?
We're talking on the order of 10 to the minus 6 degrees Celsius per pulse.
A millionth of a degree.
Exactly.
Yeah.
But that tiny thermal pulse is enough to create an acoustic pressure wave.
A thermoacoustic process.
That's it. And that pressure wave travels directly through the bone in your skull, straight to the cochlea. Your normal hearing system is completely bypassed.
So your skull is basically acting like a speaker, and your brain becomes the final transducer, interpreting that vibration as sound.
Your brain does all the heavy lifting.
Hmm.
But that's where the first major problem showed up.
Right, because just pulsing raw speech at someone's head, that can't work perfectly.
It's a disaster. The human head, it turns out, is a really effective acoustic filter. It creates this severe high-pass effect, a huge signal roll-off,
So the audio just gets distorted.
into an unintelligible high-pitched squeak, completely useless for communication.
So how did they solve that?
This is where the O'Loughlin model becomes so critical. Engineers realized they had to counter-distort the signal before it's even transmitted.
Wait, so you deliberately damage the signal in the exact opposite way. You know the head is going to damage it.
That's the elegant solution. They
Yeah.
apply a very aggressive de-emphasis filter to the audio input.
Like putting a negative filter on a photo because you know the screen it's going to be on has a weird positive filter.
You got it. The precompensation ensures that after the head does its natural filtering, what reaches the brain is a flat frequency response. Perfectly clear speech.
Incredible. Okay, let's switch gears. That's microwaves. What about acoustics? There's this other method, S-Quad.
Yes, silent sound spread spectrum. This was pioneered by Oliver Lowry, and it's a completely different approach using ultrasonics.
So high-frequency sound we can't consciously hear.
Typically around a 14,500 hertz carrier, it's right at the very edge of most people's hearing range.
And the mechanism here is called slope detection.
Right. It cleverly exploits your own ear's anatomy.
Yeah.
After about 15 kilohertz, the sensitivity of your hearing just drops off a cliff. It's a very steep slope.
And the system uses that drop-off.
It uses that slope as a natural demodulator. The signal is frequency modulated, so it shifts up and down that slope. When it shifts up, the perceived loudness plummets. When it shifts down, it gets louder.
And that change in amplitude becomes the signal.
And your brain demodulates it subconsciously. You never consciously hear the carrier signal, but the message gets through.
The sources get a little unsettling here, mentioning emotion signature clusters.
That's the claim, yes. That you can encode patterns that mimic human emotional EEG states onto that ultrasonic carrier.
To induce a feeling, like anxiety or compliance.
Allegedly, yes.
Well,
All below the threshold of conscious perception.
and this ties into another phenomenon, right? Ghost voices.
That's parametric arrays. It's another ultrasonic trick. You fire two focused ultrasonic beams
Okay.
where they cross in midair, or when they hit a hard surface like a window, they interact and demodulate right there.
Creating a sound source out of thin air.
Mhm.
Or making it seem like a voice is coming out of a window pane or, car speakers that are turned off.
Exactly, a highly localized virtual sound source.
So what does all this mean if you think you're experiencing this? The forensic challenge seems immense. You can't just record it on your phone.
Absolutely not. For the V2K microwave signal, you'd need specialized gear, a software-defined radio, and you'd need to be looking for specific pulse trains in the 700 to 2500 megahertz range.
And for the S-Quad ultrasonic signals.
You need a research-grade microphone that can even pick up frequencies that high, maybe up to 100 kilohertz, with a very high sample rate. Standard equipment is blind to it.
So the technical reality is that methods exist to completely bypass our normal ways of hearing.
Both thermoacoustic and ultrasonic, the technology is confirmed.
Which leaves us with a final thought for you to consider. If the signal can't be detected with normal instruments, and the sound really only exists in the brain's final processing,
where the signal becomes perception.
then how critical does it become to study the brain's own electrical signature, that a periodic 1/Sleff slope, as maybe the only true biomarker for verifying that these unique auditory experiences are actually taking place?